Hi, everybody. Welcome once again to my home. Let's go ahead and do it. Let me share my screen, my visualizer. That looks all right. Hopefully the video quality is decent. Go ahead and zoom in just a tad here. That's a little better. It's centered. Centered. Sorry. There we go. Cool. All right. So today, class U. I should probably tilt this a little bit. Sorry. One sec. There we go. Class Q. So we're going to do more graphing sine and cosine. But specifically, we're going to be graphing sine and cosine. So last time we did some vertical shifting and some vertical stretching, or dilations for that word. Now we're going to do it horizontally. So we're going to do some horizontal shifting. We'll probably do that second. So let's actually write the horizontal dilations. So another way to think about that is a stretch or a squash, but really specifically for sine and cosine, when you're lengthening or shortening how long it takes to get one period, you're changing the period length. So AKA, we are changing the period. And we'll talk about that a little bit. And then the other thing we'll probably get to is horizontal shifting or phase shifting. That's it. So we'll start off with one example, kind of talk about why the period changes the way it does when you change something, and then we will do some examples. So let's look at this first example. We're going to graph y equal to sine of 2x. And we're going to talk about why the period does what it does. So the short answer to the question, how does the period change, is you take whatever the coefficient of x is in the trig function, and you take your normal period and divide it by that. So the short answer here to the longer question is that the period is going to equal 2 pi divided by 2, which is pi. Or in general, now we'll save the general for later, but well, no, we'll say it right now. So generally, if you have y equal to sine of some coefficient times x, or y equal to cosine of some coefficient times x, the period is equal to 2 pi divided by that coefficient. That's the usual rule. Here's why it works this way. So normally, if you were graphing sine or cosine, you would say, oh, if we want to get one full period or one full cycle, we would let the angle go one full revolution around the unit circle. So if you're graphing one period of y equal to sine of x, what we do is we let x go from 0 all the way to 2 pi. So we get one full cycle. And that looks like this, right? You go all the way from 0 to 2 pi, split that up in half, and then each of those in half again. Normally I draw my 4 corners of a circle. I'm not going to this time. So right, we'll see. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of 2 pi is 0. And you get this nice, usual looking sine graph. Okay, it could look a little better. But now here's the thing. If we're graphing sine of 2x, we are calling our angle 2x, right? 2x is the thing we are taking sine. So 2x is the angle. So now what we're going to do is for y equal to sine of 2x, we want, I should have done this like this, we want x to go from 0 to 2 pi. Well, here we want our angle 2x to go from 0 to 2 pi. So 2x is bigger than or equal to 0, all the way up to 2x being less than or equal to pi, and everything in between. But then if we're actually graphing x values on the x-axis and y values on the y-axis, well, we have to see what x is actually doing here. So if I divide everything by 2, I get 0 divided by 2 less than or equal to 2x divided by 2 less than or equal to 2 pi divided by 2, which just gives me 0 less than or equal to x less than or equal to pi. So to get one full period of y equal to sine of 2x, I want x to go from 0 to pi, not 0 to 2 pi. Here's another way of seeing how this works. 2x is our angle. And normally when we're thinking about graphing sine or cosine, we draw our 4 corners of our unit circle, say, okay, our angles are the usual quadrantal angles, 0 degree, 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, or 2 pi radians. And then the points are 1, 0, 0, 1, negative 1, 0, 0, negative 1, all the way back to 1, 0. And sine is the y coordinate, x and cosine is the x coordinate. So sine of 0 is 0, sine of pi over 2 is 1, and so on and so on. Well, now 2x is my angle. So I want 2x to take on these quadrantal angle values. So I want 2x to equal 0, or pi over 2, or pi, 3 pi over 2, and 2 pi. And I know that sine of 2x, well, sine of 0 is 0, and sine of pi over 2 is 1, and sine of pi is 0, and sine of 3 pi over 2 is negative 1. Finally, sine of 2 pi is back to 0. But those are the values that 2x is equal to. So if I want to go backwards this way and say get to x, well, I have to divide. 2x divided by 2 gets me x. Well, 0 divided by 2 is 0. Pi over 2 divided by 2, or pi over 2 times 1/2, is pi over 4. Pi divided by 2 is pi over 2. 3 pi over 2 divided by 2 is 3 pi over 4. 2 pi divided by 2 is pi. So these are the actual 5 important x values that are going to go on my x-axis, and these are the usual y values. I'm going to try and graph it here, just so you can see it compared with sine of x. So there's sine of x in blue, and then here in red. Now my period goes from 0 to pi. And then I'm breaking up that period into 4 new quarters. So break it in half, and then each of those in half again. There's pi over 4, pi over 2, 3 pi over 4. Let me zoom in so you can see that better. Hopefully you can see that better. Let me refocus here. Cool. So then, when x is 0, sine is 0. When x is pi over 4, 2 times x is pi over 2, and sine of pi over 2 is 1. When x is pi over 2, 2x is pi, sine of pi is 0. We get the usual points, for the usual middle, top, middle, bottom, middle. They're all just compressed into half the horizontal space. So here's what this new sine of 2x looks like. The same as sine, just scrunched up into half the space. Another way to think about what's happening here, I wrote y equals sine of 2x here. If y equals sine of 2x, you get twice as many full periods in the same 0 to 2 pi. So I could draw this again and get another full period between pi and 2 pi. Not required, just worth noting. So whatever, so like if this was like sine of 5x, I would get 5 whole periods between 0 and 2 pi. Interesting. So that's kind of the background for what we're doing. But as far as how we're going to do it, the way I usually think about doing this is kind of the same way we've been doing the other stuff. We're going to find our 5 points. We're going to plot them. Then we're going to do sine. Sine is going to be middle, top, middle, bottom, top. If it's cosine, it's going to be top, middle, bottom, middle, top. And then if you have a negative out in front, you're going to flip it. So let's go ahead and use some graph paper, because let's make our lives a little easier on ourselves. So try and not get everything out of order here. We'll do our best. Oh yeah, I've done this. Sorry, I've done this weirdly here. Do I want to flip this around? Not really. Do I want to flip this? Sorry, I'm gonna think if I can change the scale here. Sorry, I'm gonna change the screen. Yeah, that's a little better. Hopefully it doesn't look too weird the way I've just changed that. All right. Actually, you know what? Sorry, I know I just changed it. Let me change it back, because I think I'd rather zoom in on my graph than have. Oh my gosh, sorry. Technical difficulties. Feel free to fast forward to where it gets interesting again. I'm gonna do it like that, and then just, yeah. Sorry, I know I'm messing with stuff all over the place here. Cool, so let's zoom in a bit so that we can see what's going on. Right on, okay, cool. So let's try graphing something like y equal to cosine of 3x. So here's what we're gonna do. We're gonna look at what the new period is. So my new period is gonna equal 2 pi divided by 3. And then the breaking in half and then breaking each of those in half again becomes a little bit more challenging. So let's just mark it off. Let's say here's 2 pi over 3 just to make it easy. I'll point out that 2 pi over 3 is about equal to 2, right? Pi is about 3, 2 times pi is about 6, 6 divided by 3 is about 2. So we don't have to be precisely to scale, but if we're trying to be to scale, that's where I put 1, that's where I put -1 for my amplitude. So I can think about this as cosine is going to start at the, so again, breaking this in half, and each of those in half again. Cosine is going to start at the top, then middle, then bottom, then middle, then top. And so I've got the right look here. The problem is, and this is something I consider to be a problem, I haven't labeled or found these x values. I know this is 0, right? But I don't know what these other 3 are. So here's what I would do. Here's the way I think is easiest to do it. I know that each of these x values represents being another quarter of the way through the cycle, or another end of a quadrant. Now, they're not typical pi over 2, pi, 3 pi over 2, and 2 pi because we've scaled things down. We've made our period smaller. So what we're going to do is we're going to say, well, if that's the period, 1 quadrant length, which I know is a lot to write, I would really just write 1 quadrant length is 1/4 of my period, or my period divided by 4. That's just going to equal 1/4 times 2 pi over 3. That's going to be 2 pi over 12, which reduces down to pi over 6. So my first x value, which I like to call x sub 0, is 0. And then my next one is just going to be 1/4 or 1 quadrant away. So this length here is 1/4 of my period. And that's equal to pi over 6. 0 plus pi over 6 is pi over 6. So this next point here, pi over 6, but I like to call it x sub 1 is 0 plus pi over 6, which is pi over 6. The next point is another pi over 6 away. That's another quarter of a period. Well, my next point, x sub 2, is my previous point, pi over 6 plus another pi over 6, which is 2 pi over 6, which we could reduce, but I don't really want to. I'm going to reduce it in my head and say it's pi over 3. So here's pi over 3. But the reason I don't want to reduce it is because when I add on another quarter of a period, which is still pi over 6, I'm going to get my third value being 2 pi over 6 plus another pi over 6, which is 3 pi over 6, which I know reduces to pi over 2. Finally, my last point is going to be my previous point, 3 pi over 6. I'm starting here at 3 pi over 6 and adding another quarter of a period, which is pi over 6, to get 4 pi over 6, which does reduce to 2 pi over 3. So these are my, I like to call them 0, 1, 2, 3, 4 points, but my 5 important points that I'm labeling x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. We might just talk about the horizontal stretching today because it seems like this video is going to go long if I try and do both. All right, so let's do a few more examples. Sure. Oh, sorry, I've got that. Sorry, well, but that was on the whole slide. Right. So anything else I want to say about this here? Not really. I will point out, I said not really when I say things. So if we were going to graph this, or if we we're going to continue graphing this, we would get 3 full periods in a length of 0 to 2 pi. Right? 0 to 2 pi over 3, then 2 pi over 3 to 4 pi over 3, then 4 pi over 3 to 6 pi over 3, which is equal to 2 pi. Yeah. Let's do another example. Let's kind of go the other direction. Let's say I want to graph y equal to, sure, let's make it more fun, 3 sine of 1/2 x. Okay. So here's where we start just kind of saying, I'm going to try and think about this relatively easily. So my period here is going to be 2 pi divided by 1/2, which is the same as 2 pi multiplied by 2/1, which is 4 pi. And then I know I'm going to break up my period into 4 quarters. So 1/4 of my period, or 1/4 times my period, is going to be 1/4 times 4 pi, which is just pi, which is probably really easy to see, but whatever. Great, let's say I'm going to try and use these spaces to my advantage. Since I know I'm going to be breaking stuff up into 8, or I mean up into quarters every time, I'm going to either pick lengths that are 4 long or kind of 8 long, so it's going to be easy to break up into quarters. So if I say that's my period length of 4 pi, then I'm going to break that in half and half again. And then, sure, my amplitude is 3 here, so I'm going to go up as high as 3, down as high as -3. Okay, right, these are not to scale, right? This length here is representing 1 pi. This length here is representing 3, which is close to the same number, but the lengths aren't the same. That's okay. Let's continue here. So again, my starting value, if I don't have a horizontal shift, which we haven't talked about yet, or a phase shift, your starting angle is always going to be 0. And then my next value, I'm just going to add on, oh, I know what I want to do before, 1/4 my period. My next value, I'm just going to add on to my previous value, another 1/4 of my period. My next one is going to be 2 pi plus pi, which is 3 pi. I don't think you need to show all this adding. I'm just showing you that's how it works. You'd be like, oh yeah, I know pi plus pi is 2 pi. I know 2 pi plus pi is 3 pi. But what should always happen here is your beginning value, if you haven't done a phase shift, should be 0. And your end value should be, excuse me, the value of your period length, which is 4 pi in this case. So 4 pi, cut it in half, you get 2 pi. Cut each of those in half, you get pi, and then between there is 3 pi. Or you can say 0 plus pi, plus pi, plus pi, plus pi. 4 quarters of your period equals 1 whole period. So graphing this, so 3 sine of 1/2 x. So my sine starts at the middle, and then goes up to the top, and then back to the middle, and down to the bottom, and then back to the middle. We graph it as best we can. A lot of these graphs are going to look the same because they're all just sinusoidal functions being stretched and shifted. I will say each quarter looks like every other quarter, just rotated. So this first quarter looks like this, then I flip it that way to make it look like that. Then I flip that, or I rotate this 180 degrees down there, look like that. And then I flip this one again that way, look like that. But they literally are identical to each other. They're just reflections or rotations of each other. Let's do a few more examples. Yeah, we'll go different examples. We'll kind of put it all together here. So let's add in some shifting as well as some stretching. So let's try doing y equal to, oops, sorry, you can't see that, apologies. Let's try y equal to, I don't have a whole lot of vertical room here. I might pull out my other graph paper. We'll try this for now. Let's try y equal to 1 minus 2 cosine of, let's say, oh yeah, that's a fun one. 3 halves x. Okay. First and foremost, I would probably rewrite this. I like to have my vertical shift coming last. So I would write this as -2 cosine of 3 halves x plus 1. My amplitude is 2, not -2. My vertical shift is up 1. And my negative out here means I'm going to have a negative reflection. So I'm going to flip it vertically across the x-axis, essentially. So I have a vertical reflection, which means instead of being the usual cosine of top, middle, bottom, middle, top, we're going to go bottom, middle, top, middle, bottom. And then the period stuff. So my period here is equal to 2 pi divided by the coefficient of x, which is 3 halves. Oh, sorry. There's something I keep meaning to do in the previous ones, and I'm just going to go back for 1 second. So what I was meaning to do with the previous ones is show, like, really, like, for this value, I'm just taking this and then adding pi over 6 to the next one. And then I'm taking pi over 6 and adding pi over 6 to the next one. I'm taking 2 pi over 6, adding pi over 6 to the next one. Taking 3 pi over 6, adding a quarter of my period to get the next one. Same deal here. 0, 0 plus pi is pi. Pi plus pi is 2 pi. 2 pi plus pi is 3 pi. 3 pi plus pi is 4 pi. That's the idea. You're just taking your previous kind of quadrantal angle, or what's substituting in for the quadrantal angle, and then adding the 1/4 of your period, right? Because 1/2 times pi is 1/2 pi, and 1/2 times 2 pi is pi, and 1/2 times 3 pi is 3/2 pi, and 1/2 times 4 pi is 2 pi, which gives you your actual quadrantal angles. Okay, so back to this. Sorry, I got a little off track there. So our period here is 2 pi divided by 3/2, and whenever you divide by a fraction, you do 2 pi multiplied by 2/3. You can make this 2 pi over 1 if you want to. You don't have to. That ends up being 4 pi divided by 3. So I know that's the total length of my period, and then 1/4 of my period, or 1/4 times that period, is 1/4 times 4 pi over 3. You could get 4 pi over 12, but then you should reduce that to pi over 3. And you can think of those 4s canceling, or you could go 4 pi over 12, and that's equal to pi over 3. So my x values, my starting place is going to be 0. My first x value after that is going to be 0 plus pi over 3. You don't have to write out 0 plus pi over 3. My second place is going to be pi over 3 plus pi over 3, which is 2 pi over 3. My third value, or my fourth value after 0, okay. My x sub 3 is going to be pi over 3 plus 2 pi over 3, which is 3 pi over 3, which is pi. And my last value, my fifth value, x sub 4, is going to be 3 pi over 3 plus another pi over 3, which is 4 pi over 3. And that gets me one full period from 0 to 4 pi over 3 that has a length of 4 pi over 3. Cool. Let's see, 4 pi over 3 is about 4. Sure, let's try and make it look scale-ish. So there's my 4 pi over 3. I might not actually label these here because it might get kind of messy, so I'll wait to label them, or just kind of make it easier. If I've written this over here, I think it's sufficient to be like, yeah, there's x sub 0, 1, 2, 3, and 4. All right, so then negative 2 cosine plus 1. So I'm shifting up 1. So I like to draw my new horizontal, my new middle line, as I call it. And then my amplitude is 2. So I'm going to be going 2 above to a height of 3, and 2 below to a depth of -1. And then that's 1 right there. Okay, so normally cosine would start top, middle, bottom, middle, top. Since we've got a vertical reflection, we're going to start when our angle is 0 at the bottom of our range. And then the next important x value, we go up to the middle. Next important x value, we go up to the top, back to the middle, back to the bottom. So it's going to look something like this. And yeah, we can label these. This would be pi over 3, 2 pi over 3, 3 pi over 3, which is pi, and 4 pi over 3. If you don't like that, you could alternatively label them as x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4, as long as you've written what x sub 0, 1, 2, 3, and 4 are equal to over here somewhere. Cool. Oh, let's do a couple more examples and then probably call it a day. So yeah, let's try that one. So let's try, this one will be a little bit messier. So we'll do y equal to, yeah, we'll go with the sign as well. So let's say we've got, sure, -2 minus sine of 2/3 x. So again, we have all the things, and I would really prefer to write this. Well, we don't have all of it. We haven't talked about phase shifts yet, but we have all the things we've talked about so far as graphing sine and cosine. So I would like to write this as negative sine of 2/3 x minus 2. My amplitude is 1. I don't usually write that because if the amplitude is 1, it's kind of like that's what it usually is, but you can write it. My vertical shift is down 2. And my other thing I have to be aware of is my vertical reflection is something that is happening because of that negative out in front of the function. What else? Oh yeah, my period. So my period is 2 pi divided by the coefficient of x, which is 2/3, which is going to equal 2 pi over 1 times 3/2. 2 pi times 3/2 is 6 pi over 2, which is equal to 3 pi. That's my full period. So then if I want to find my important x values, I know I'm going to start, well, before I even write down that x0 equals 0, I should really find my period broken up into 4 equal quarters, right? Because I'm just saying, and I'm going to make this one longer. I'm going to go, so I'm going to say that's my full period length of 3 pi. You could do this a different way, right? I just have found this to be easy, but if you prefer, you can be like, yeah, I'm going to cut this in half. That's 3 pi over 2. I'm going to cut that in half again. 3 pi over 2 divided by 2 is 3 pi over 4, or 3 pi over 2 times 1/2 is 3 pi over 4. The only hard part, if you do it this way, I think, is finding this one here. You can either do like the average of these two numbers. You can be like, well, this is 3 pi over 4. This is 3 pi over 2. This is going to be 9 pi over 4. But I feel like that one's a little harder to come up with. Whereas if you do it this way, so my x of 0 is 0. A quarter of my period is 3 pi divided by 4, or 1/4 times 3 pi. So then my x sub 1 is 0 plus 3 pi over 4, which is 3 pi over 4, which matches up with what we have here. My x sub 2 is 3 pi over 4 plus 3 pi over 4, which is 6 pi over 4, which is 3 pi over 2, just like we have right there. My x sub 3 is, this is the one that was hard to think of, 3 pi over 4 plus my 3 pi over 2, my previous value, plus my quarter of my period. But 3 pi over 2 is 6 pi over 4. So it's 6 pi over 4 plus 3 pi over 4, which is 9 pi over 4. Which is exactly what we've got right there. And then finally, my last one, 9 pi over 4 plus 3 pi over 4 is 12 pi over 4, which is 3 pi. So I feel like this way is a little more algorithmic. Like if you know how to do the process, you always come up with the right 1, 2, 3, 4, 5 values. But if you prefer, you can be a little bit more savvy and be like, okay, well, yeah, I know 3 pi. I know this number divided by 2 gets me that. That divided by 2 gets me that. And then you can do this plus whatever that is, get you that. That's like, I want to do that. Anyway, there's lots of ways to get there. So now we're shifting down 2. And our amplitude is 1, meaning we're going up as high as -2 plus 1 and down as low as -2 minus 1. Again, we've got a vertical reflection, so sine would usually go middle, top, middle, bottom, middle. But now we're going to go middle, bottom, middle, top, middle, because that's what the vertical reflection of sine is going to do. If you're not sure if your graph is looking right, you can actually plug in a value and check. Again, you have to be confident in your trig evaluation abilities to do that, but it does work. For example, I can be like, maybe let's just double check. So if I plug in 3 pi over 4, x is -3 pi over 4, then y is going to equal negative sine of 2/3 times 3 pi over 4 minus 2. 2/3 times 3 pi over 4, the 3's cancel. 2 pi divided by 4 is pi divided by 2. So I really have negative sine of pi over 2 minus 2. Sine of pi over 2 is 1. It's the top of my 4 corners of my circle. So you get -1 minus 2, which is -3. And that checks out. When x is 3 pi over 4, y is equal to -3. All right, I've probably done enough examples. It's been just about 30 minutes on the timer, so I'll spare you any more lecturing, and we'll talk about the phase shifts another time. All right, I hope this was not too unenjoyable, and I will see you all on Monday. Bye.